Recently, the MIT Enterprise Forum of Cambridge hosted an Innovation Series panel focused on climate change, featuring remarks by Professor John Sterman, a professor of system dynamics and engineering systems at MIT, and a leading climate change expert. Professor Sterman has been featured on media around the world, including the New York Times, the Boston Globe, Public Television's NewsHour, National Public Radio's Marketplace, and WGBH. I'm Randy Kronk of GreatWriting.com and a volunteer at the forum. I caught up with Professor Sterman following the Innovation Series event so that I could ask him to elaborate on some of his views on climate change and what can be done about it. I began by asking him about the role technology innovation might play.
Well, there's no doubt, of course, that innovation is essential to address the climate problem, but it's also not sufficient. And it's not sufficient in a couple of ways. First of all, innovation doesn't mean scale up, doesn't mean broad scale adoption, and it doesn't mean acceptance by the people who are affected by those innovations. So it's also necessary from I think quite early in the process, to engage the affected stakeholders. So in the case of smart building technology or microgrids or remediation technologies to address sea level rise, extreme weather, or other impacts of climate change, where there are many exciting opportunities in the technology space, it's also essential to reach out to community activists, to housing activists, to the people in neighborhoods all across the cities you want to innovate in, so that they're engaged in the process. And not just as, here we have a technology, we'd like to put it into your city or your neighborhood, but here's what we think we might be able to do. Would this meet your needs? That is, going very far upstream in the process to engage the people who would actually have to live and work with the technologies in homes and in commercial properties, in industrial properties, and make sure that you're listening to them as to what they actually need, what would make their lives better, what would actually make their homes more comfortable.
In the panel that we just held, there was a lot of talk about adaptation versus mitigation. Why do you believe that adaptive methods are insufficient and in some cases even counterproductive against climate change?
Well, there's no question that we're going to have to invest in adaptation. We've already warmed the planet more than halfway to the 2 degrees C, 3.6 Fahrenheit limit that was established and reinforced at the Paris climate talks. And of course, everybody needs to realize that 2 degrees C, 3.6 Fahrenheit is not safe. Even though that's the number that's been codified in the agreement, it is not safe. It's just less harmful than going above 2, and that's where we're headed under business as usual. So it's a stretch to try to limit warming to 2, but even if we do, there's going to be a need for adaptation. We already see the harmful impacts of climate change. Sea levels are rising now. Many coastal communities are being flooded at king tides and even ordinary high tides now. We're already seeing more extreme weather that kills people during extreme heat waves. Now we're seeing declines in forest health. We're seeing declines in agricultural yields. We're seeing droughts. There's a huge array of impacts that are already happening now, and there's far more that will be occurring as the warming that's already locked into the pipeline because of the greenhouse gases we've already spewed into our atmosphere continue to warm our planet. So there's no question adaptation is necessary, but it's not possible to adapt to a world of business as usual warming. Estimates vary, but if we continue on the trajectory we're on, by 2100, absent full implementation of the Paris Agreement and even more aggressive actions, more ambitious actions, we're headed for warming between 3.5 and 4.5 or more C. And the breadth and severity of the impacts that are likely to occur in a world that much warmer than we have today are so great that there's no meaningful prospect for adaptation.
Let's use Massachusetts as an example. What do you see as the impact in Massachusetts in the short term or further in the future?
So there's both local impacts, sea level rising, more extreme weather, likelihood of more severe storms, perhaps on the scale of Hurricane Sandy. But Boston and every other place in the world will be affected by climate change impacts that occur elsewhere. So, for example, under business as usual, it's likely that crop yields will decline significantly all around the world, and especially in the poorest countries of the world, such as many of the countries in Africa. And those crop yield declines are potentially very large. Well, that would raise food insecurity, which is the UN's euphemism for starvation, as well as food prices all over the world. If millions of people are suddenly starving as a result of climate change, there will be refugees, there will be conflict, there will be mass migrations, and that will have a huge impact on the people of Boston, even if nobody in Boston is hungrier than they are today. And you want to think about this not just in terms of, food prices might go up and there could be famine in Africa. You want to think about this as there could be wars that would make the conflict in Syria and the migration that's resulted look like just a few people going on holiday. So, for example, sea level rise alone in the Indus Delta on the border of India and Pakistan is likely to displace many millions of people on a hot contested border between two countries who don't get along very well now, and both of which have nuclear weapons. So people need to stop thinking about local impacts. We're going to build seawalls, we're going to put some buildings on stilts, etc. That's just not enough, even if it ends up being necessary.
So you're a professor of systems dynamics and engineering systems at MIT, and these are disciplines that obviously apply to many different domains. What is it about their application to climate change specifically that intrigues you?
Well, climate change may be the perfect storm of complexity and confusion. Obviously, the climate is a highly complex dynamical system, but it's also got aspects that are challenging for policy and for public understanding. First of all, people think it's very far out in the future and that we can therefore wait and see how bad it's going to be before we take action. But the long time delays in the climate system and in the economy and the social system mean we can't do that. So anybody who's ever boiled a tea kettle on their stove knows that you can wait until the teapot whistles to pull it off the heat, because there's no lag between the whistle, your reaction to the whistle, and your removing the pot from the flame. That's not how the climate works. By the time we wait for the whistle, that is unequivocal evidence that climate change is going to be severely harming. We already have evidence today, and people are largely ignoring it, at least at the federal level. But if we wait for that evidence to become unequivocal, then we can't just stop the climate change. Think about all the steps there, right? First, people have to recognize that the climate is changing in ways that are so serious that we have to respond. Then we have to build the political support to pass legislation and change regulations and put into place other policies that would begin to reduce emissions. Once you do that, it still takes a long time for emissions to fall because you have a large installed base of vehicles and buildings that are inefficient and settlement patterns that require people to drive long distances, and on and on and on. And these elements of our physical infrastructure and economy change only slowly. The average new car today lasts for at least 15 years. So, and buildings for far longer. So you have very long delays even before emissions start to fall. And then there are long delays between a drop in emissions and a stabilization or decline in atmospheric greenhouse gas concentrations. And then there's even longer delays before the temperature of the planet can begin to respond. And then impacts like melting glaciers, changing weather patterns, and so forth would begin to respond. So those delays are so long, we have to act today. There's not 1 minute to lose.
I'm just curious if you were doing one of your classes and you were going to, I'm sure you probably do this, using climate change as a case study in one of your systems thinking or systems engineering classes. What examples from climate change would you bring into the classroom? For example, what features do complex systems have in common, and why do they matter specifically in the climate change context?
So we do this, but here's what we've learned. You can't tell people this. You can't change how people think and especially how they behave and their engagement with this issue by telling them anything, by lectures. It just doesn't work. The social science research is very clear. In fact, the way I sum it up is research shows that showing people research doesn't work. This is very well established. And yet the vast majority of communication around climate change is let us, the experts, tell you, the poor benighted public, what's likely to happen and how climate change works. And that's just ineffective. And it's ineffective in many domains, far, far simpler than climate change. Medical professionals, public health professionals have been telling people for decades that, stop smoking, wear your seatbelt, motorcycle helmets, and still, although there's progress, it's very slow, and there's large fractions of our society who won't wear their seatbelts. So this idea that experts will simply tell you the facts and then you're going to make decisions or government leaders will enact policy that is consistent with the science, that's just dead wrong. So we don't do that in our classes. What we do instead is we've created a set of interactive simulations, system dynamics models that represent the climate and the energy system, peer-reviewed, carefully calibrated to replicate the behavior of the very large supercomputer-based climate models that are used in research, but they run in less than a second on an ordinary laptop. And that creates the opportunity for people to learn for themselves by experimenting, by running multiple scenarios, by debating with their colleagues. So those models are used by policymakers in the UN, in the United States, at least up until the current election, and in other countries, France, Brazil, China. And that's helpful to policymakers, but it's still not enough because it doesn't help the public and doesn't build the grassroots support that policymakers would need in order to enact the legislation and policies that would actually bring emissions down. So we have embedded our interactive simulations in a role play of the UN climate negotiations. We call it World Climate, and everybody can go to climateinteractive.org and learn all about the models and the role play, and everything there is free. So what happens is students or business leaders, executives, policymakers will come into the workshop and they'll play the role of the negotiators in the climate talks. So you have people from the US and the European Union, China, India, and so forth. And they get a little briefing in the form of an introductory charge from the Secretary General of the UN. And when I run it, I get to play now Antonio Guterres. And then they negotiate face to face. And they are in charge of their own learning. They decide what, if any, emissions reductions they are willing to undertake from the country that they represent in the negotiation. And then we take all their presentations, all their proposals, and run them through the simulation model right there. And they get immediate feedback showing how much emissions might fall globally and what the impacts of that would be. It's very common that the first round of negotiations produces some progress, but not enough to limit expected warming to no more than 2 degrees C. And this is pretty shocking for a lot of people because they can see that collectively their emissions are stabilized or maybe even falling a bit, but the temperature keeps going up and the CO2 in the atmosphere keeps going up. And we use the model to help them understand why that's happening. It's pretty simple. The amount of carbon dioxide in the atmosphere is just like the amount of water in a bathtub. And if you fill your bathtub faster than it drains, Everybody knows the water's going to rise, and if you don't do something about that, it's going to overflow and destroy your house. So it's exactly the same thing here. We're spewing CO2 into the atmosphere more than twice as fast as it's removed by biomass and dissolving in the ocean. And so just stabilizing emissions, just stopping the growth of emissions, does not stop the growth of the concentration. It keeps rising. So if you just tell people that in a lecture, nothing happens. But if they are motivated to understand why didn't emissions, why didn't the temperature fall when emissions fell, then that's a learning moment. So after that, and some further discussion, they go back and negotiate again. And when it works, which it often does, and remember, we're not telling anybody what to do. They decide. But when it works, there's a shift that arises spontaneously from the participants, where in the beginning, they come in with the usual zero-sum distributive frame for a negotiation. So if you win, I lose. And they shift on their own to a more integrative frame where people realize their common interests and find those win-win opportunities, that we're all in the same boat here and we can work together for everyone's mutual benefit. And that's not something we tell them, it's something they discover. So as of today, as we're speaking in early February, 30,000 people around the world have participated in this role play in just about the last year and a half, and it's growing pretty rapidly. And it's all over the world. It's not just in North America and Europe and the other developed economies, but lots in Latin America and Africa and India and developing nations.
I have to say that's a pretty good marketing communications model that you've developed.
Well, 30,000 isn't nearly as many as it needs to be.
But it's effective. It's engaging.
But it seems to work. And we've actually been carrying out assessment research to answer the question, does it actually work, or is it just something that people say is a lot of fun and they learned a lot? So we've done a study that's about to be submitted to a journal, so warning, not yet subject to peer review. But what we have done is collect people's knowledge and beliefs about climate change through surveys before the experience and then sometime after. And that research shows there are, in fact, significant gains in people's knowledge of the climate science, understanding of the impacts, and especially their affective engagement, the emotions and feelings that they have, how urgently they feel it is necessary to act, whether they're hopeful or discouraged, and their intent to do something in the real world. And people come out more engaged, more concerned, more hopeful that what they personally do can matter, and expressing their intention to get active and do something in the real world, whether it's cutting their own carbon footprint or getting politically active. So we're pretty excited about this, and I'm persuaded, having made every possible mistake one can make in the classroom, that kind of learner-directed, interactive simulation is just about, well, let me just say it's the only effective way to teach about, or for people to learn about these issues that I know of.
So I have to ask you, are you an optimist or a pessimist when it comes to the struggle against climate change?
So there's an old joke where the optimist proclaims, this is the best of all possible worlds, and the pessimist says, that's right. By that definition, I'm neither an optimist nor a pessimist. I'd rather I don't believe this is the best of all possible worlds. I think we can make a difference. We can improve things through technology, through social change, through political activism, and that it's not only possible, but given the gravity of the challenge here, it's a duty. And so people say, well, are you hopeful we can solve this problem? So I'm hopeful in the following sense. I'm not making a prediction. I'm saying we have a choice, and I'm choosing to be hopeful. I'm choosing to believe that what individuals do matter, because that's the only way we can make a difference. If everybody believes we can't do it, it's too late, I'm just one person, nothing I do matters, then we're going to be right. So it's, for me, choosing hope, it's not only what I have to do, but it's also essential for my personal well-being. To go into denial or despair or to say it's too late, that's just unacceptable, and it's disempowering and depressing.
In your writings, you've made parallels between the climate change issue and other great challenges that society has faced in the past. Can you talk a little bit about that?
Well, this is one reason why I'm hopeful. I think, obviously there's been a huge, long record of amazing technological innovations that nobody really anticipated but have completely transformed our world, often for the better. Not always, and many of those innovations, of course, have unintended harmful consequences, many of which only manifest later. I mean, examples are legion. The automobile solved the horse manure problem in our cities, but then created a smog, public health, auto accident fatality, and climate problem. DDT was a miracle and was able to make a huge difference after World War II, but had obvious harmful consequences that are still being felt today. So no technology is free of so-called side effects, but still, I don't know many people who would want to trade the medical system we have today for all its problems with the situation in 1900, where if you pricked your finger and got an infection, you were at risk of dying because there were no antibiotics. So I'm very, very hopeful about technological innovation. I believe in the power of human ingenuity there. But it's also not nearly enough for the reasons we've discussed. We need social change as well. So I'm constantly told by people that it's naive to think that we could turn around public indifference and on this issue of climate change. And this is extremely important. This is why climate change is no longer about the science. It's a political issue, it's a social issue, it's a personal moral issue. And on that score, I look at what's been happening in the world, and there are many situations in which terrible conditions, things that nobody thought would ever change, actually changed. So, for example, in my lifetime, when I was young and for many years after, nobody believed that they would live to see the fall of the Berlin Wall or the end of the Soviet Union, and yet we did. Nobody believed we would see peace in Northern Ireland, and yet we have peace in Northern Ireland. There are still, of course, grievances and hatred even among those folks, but they're not killing each other. Nobody believed that there would be an end to apartheid in South Africa, or that if it did end, it would only be as a result of a long and bloody civil war, and yet it ended peacefully. There are many, many other examples. This is, I think, another aspect of complex systems. Institutions that have been in place for decades, centuries, or even longer can suddenly change as a result of people becoming active, people becoming aware, and shifting from it's just the way it is, it may be regrettable, but it's always been that way and it always will, to this is morally wrong and we need to do something about it. Now, it doesn't just happen. It requires people to get active, but it has happened multiple times, and I think it can happen on this issue as well.
John, I think that's a great note to leave it on. Thank you very much for spending some time with us today, and good luck with your systems thinking class. It sounds fascinating.
Great. Well, thank you very much, Randy.